Application of definite integrals. First, we will try to understand what do we mean by area under a curve. So consider the coordinate system. Let the function f of x be bounded function on a closed interval AB. So we are considering the coordinate axis. Y is equal to f of x is a given curve. X is equal to a and x is equal to b are the lines parallel to y-axis. So the area under the curve y is equal to f of x and x-axis is given by the shaded region here. So dx gives the elementary area. Area is composed of large number of such vertical trips. So area under the curve y is equal to f of x, x-axis, and between the lines x is equal to and x is equal to b is given by a is equal to a to b f of x dx. Next, consider the coordinate system. Consider the curve x is equal to g of y and the lines y is equal to c and y is equal to d. Consider a strip dy. So the area is multiple of such strips. So the area under the curve is given by integration from c to d x dy. Next, be careful, y is equal to f of x. Consider a vertical strip dx. Here dx is greater than 0, y is less than 0. So y dx is less than 0. That is, area cannot be negative. Find the area enclosed by the circle x square plus y square is equal to a square. So consider the coordinate system. So the radius of the circle is a units. So the coordinates of the point A will be a, 0. Next, it can be observed that the circle is symmetric about x and y axis. Therefore, area bounded by the circle is equal to 4 times area in the first quadrant OABO. So area OABO is equal to area bounded by the curve x-axis and the lines x is equal to 0 and x is equal to a. So 0 to a. Now let us calculate y. X square plus y square is equal to a square. So y square is equal to a square minus x square, or y is equal to root of a square minus x square. Substituting the value of y, we get root of a square minus x square dx. By using the formula root of a square minus x square, we get x upon 2 root of a square minus x square plus a square upon 2 sine inverse xy. So on simplifying, we get x upon 2 root of a square minus x square plus a square by 2 sine inverse x by a under the roots 0 to a. So substituting the limits, we get a by 2 root of a square minus a square plus a square by 2 sine inverse a by minus, in place of x replace it by the lower limit, so 0 by 2 a square minus 0 square plus a square by 2 sine inverse 0 by 0 by 0 0 by a, which is equal to 0. So the first term in both the equations will be 0. So we need to simplify, and even the second term in the equation 2 is 0. So we need to simplify only one term, a square upon 2 sine inverse 1. The rest of the terms are 0. So a square upon 2, keep it as it is, sine inverse pi by 2. Sine inverse 1 is pi by 2. So the value, the area of the square is pi a square upon 4. Next question. Next example. Find the area enclosed Next example. Area enclosed by the ellipse x square by a square plus y square by b square is equal to 1. So again consider the coordinate system. Consider an ellipse with coordinates a comma 0 minus a comma 0 on x-axis and 0 comma b and 0 comma minus b on y-axis. So it can be seen that the ellipse is symmetric along both x and y-axis. Therefore, the area bounded by the ellipse is equal to 4 times area in the first quadrant. So area OABO is the area which is bounded by the curve x-axis and x is equal to 0 and x is equal to a. So 4 times the area 0 to a y. So the value of y for the ellipse will be equal to x square by a square plus y square by b square equal to 1. Y square by b square is equal to 1 minus x square by a square. B square into a square minus x square divided by a square, or y is equal to b by root of a square minus x square. So area is equal to 4 times b by a integral from 0 to a square minus x square dx. So 4 by b by a, keep it as it is. Apply the integral formula root of a square minus x square, which on simplifying we get x by 2 root of a square minus square plus a square by 2 sine inverse x by a under the limits. So on simplifying it further, a by 2 root of a square minus a square plus a square by 2 sine inverse a by minus b by 4b by a 0 by 2 a square minus 0 plus a square by 2 sine inverse 0 by so the first two terms in both the expressions will be equal to 0. Even the second term in the expression 2 will be 0. So 0 plus a square by 2 sine inverse 1 will remain, which on simplifying we get a square by 2 pi by 2, or a is equal to pi ab square units is the area of the given ellipse. Next example, find the area bounded by the curve y square is equal to x and the line x is equal to 1 and x is equal to 4 in first quadrant. Y square is equal to x is the equation of parabola opening towards the right, that is in positive direction of x-axis. So we need to calculate the area bounded by the curve y square is equal to x. The lines x is equal to 1, x is equal to 4 within the limits x is 1 to 4. So area ABCD is equal to 1 to 4 y dx. Y value is root x dx. So x raised to 3 by 2 divided by 3 by 2. So on simplifying we get 2 by 3 x square raised to 3 by 2. 2 by 3 4 raised to 3 by 2 minus 1 raised to 3 by 2. On simplifying we get 2 by 3 8 minus 1, which is equal to 7. So it will be 14 upon 3 square units. Next example. Find the area bounded by the curve y square is equal to 4x and the line x is equal to 3. So consider the parabola opening towards positive direction of y-axis. Y square is equal to 4x is the curve. So the area between x is equal to 0 and x is equal to 3. The area is symmetric about x-axis. So area OABCO is equal to 2 times the area in the first quadrant. So 2 times 0 to 3 y dx. On substituting the value of y, we get 2 times 0 to 3 2 root x, which on simplifying we get 4 into x raised to 3 by 2 upon 3 by 2 0 to 3 8 by 3 3 raised to 3 by 2 minus 0, or 8 by 3 root 27 8 by 3 root 3 root 3, which on simplifying we get 8 root 3 square units. Next example, the area bounded between x is equal to y square, x is equal to 4 is divided into two equal parts by the line x is equal to a. Find the value of a. So the line x is equal to a from the figure divides the area between x is equal to 0 and x is equal to 4 into two equal parts. So it is given that the area is divided into two equal parts by x is equal to a. Area OED is equal to area EFCD. Therefore, area of OED is equal to 0 to a y dx. Area of EFCD is equal to, so x raised to 3 by 2 upon 3 by 2. On simplifying, we get 2 by 3 a raised to 3 by 2, which is equation 1. Next, area of EFCD will be a to 4 y dx, which is equal to a to 4 root x dx, x raised to 3 by 2 upon 3 by 2 under the limits 4 raised to 3 by 2. The value of a after simplifying is a raised 4 raised to 2 by 3. Next question, find the area bounded by the parabola x square is equal to 4y and the line x is equal to 4y minus 2. So x square is equal to 4y minus 4y is the equation of the parabola. X is equal to 4y minus 2 is the equation of the line. So equation 2 and 1 can be simplified and the value of x will be equal to x is equal to 1 and x is equal to minus 2. So x is equal to minus 1 and x is equal to 2. So observing the point of intersection, we get x is equal to minus 1, y is equal to 0. So the point of intersection are okay. So further, we can see that the area bounded by the curve x square is equal to 4y and x is equal to minus 1, x is equal to 2 and x-axis is given by minus 1 to 2 y dx. The value of y is x square by 4. So on simplifying 1 by 4 x cube upon 3 minus 1 to 2. So 4 into 3, 2 cube minus 1 cube, which equals 1 upon 12, 8 plus 1, and 3 upon 4 square units is the required. Next question, find the area of the smaller part of the circle x square plus y square is equal to a square cut off by the line x upon a upon root 2. So consider the circle with radius a units. Required area is equal to 2 times a upon the root 2 to a 5 times y times dx. So on simplifying we get y is equal to root a square minus x square. So substituting and simplifying we get further x2 into x by 2 a square minus x square plus a square by 2 sine inverse x by 2 into a by 2 a square minus a square plus a square upon 2 sine inverse a by a, and the other limit is a upon root 2. Substituting the limit in the same formula and simplifying we get 0 plus a square by 2 sine inverse 2 minus 2 into a upon 2 root 2 root of a square plus 1. So 2 into 0 plus a square pi by 2 minus a 2 root 2 upon a root 2 minus a z pi by 4. So pi by 4 a square by 4 minus a square by 4 minus pi a. Next example, area between the two circles. So area bounded by the two circles x square by y square is equal to 1, x is equal to 1 by 2, x is equal to 1 and x axis. So it will be 2 times integral from 1 by 2 to 1 y dx x square by y square is equal to, so value of y will be root of 1 minus x square. So 2 times 1 by 2 root of 1 minus 1 plus 1 upon 2 sine inverse 1 by 1 minus 2 1 upon 2 1 upon 2 root of 1 minus 1 upon 2 whole square plus 1 upon 2 sine inverse 1 upon 2 plus 1. So 2 into 0 plus 5 by 4 minus 2 into 1 by 4 root of 1 minus 1 by 4 plus 1 upon 2 root 2. Next, simplifying, we get pi by 2 minus root 3 by 4 minus pi by 6, which is equal to pi by 3 minus root 3 by 4 square. Next example, so the required area is a1 plus a2, pi by 3 minus root 3 by 4, pi by 3 minus root 3 by 4. So the final answer will be 2 pi by 3 minus root. Okay. Next, the last concept in this application is the equation, the area between three vertices of a triangle. So here we are considering the three vertices a minus 1 comma 0, b 1 comma 3 and c 3 comma 2. So first we require the equations of the lines AB, BC and CA. So y minus y1 is equal to y2 minus y1 upon x2 minus x1, x minus x1. So applying the formula, we get the equation minus x plus 1 2y minus 6, or on simplifying we get y is equal to 1 by 2 minus x. Next, the equation of, so the area bounded by the line BC will be 1 2 3 y dx. On simplifying we get 1 by 2 x square by 2 plus 7x, or which equals x plus 14x by 2, or 1 by 4 minus 3 square plus 14 into 3 minus 1 square plus 14 into 1, which on simplifying we get minus 9 plus 42 minus 1 plus 30, okay, 14. So on simplifying we get 43 minus 23 is equal to 20, and 20 upon 4 is equal to 5 square units is the required area of that triangle. Similarly, we will consider one more example. So first we are calculating the equation of 1 by 2x plus 1. Similarly, the other two equations will be 1 by 2x plus 1, x is equal to minus 1 and x is equal to 3. So 1 by 2 minus 1 to 3 x plus 1 dx, x square by 2 x minus 1 raised to 3. So 1 by 2 as it is x square plus 2x upon 2 minus 1 to 3, which on simplifying we get 1 by 4 3 square plus 2 into 3 minus of minus square plus 2 into 1, which on simplifying we get 9 plus 6 minus 1 minus 2 as 1 upon 4. 16 upon 4 is 4 square units, which is the required area of the triangle ABC. So on simplifying we get 3 plus 5 minus 4, so which is equal to